Okay, so 4.2, first order differential equations, question 2a, dy dx equals 1 plus x over y minus 1. So the whole point of this is to get to an equation y is equal to stuff with x, and there'll be a c in there as well somewhere. So we obviously have to integrate to get rid of our dy dx, but you notice you can't integrate straight away because you've got both y's and x's. So if we can't integrate straight away, the first thing we try and do is separate them, and that's easily done here. Y minus 1 is dividing, so when it comes over, it will multiply. And dx is dividing, so when it comes over, it multiplies. That's nice and neat, because now I've got my y's with my y's, my x's with my x's. So I'm ready to integrate both sides. So I integrate the left, I get y squared minus y, y squared over 2 minus y equals x plus x squared over 2. And I'll leave out my c just for the moment. And to simplify this, I'm just going to multiply everything by 2. So when I multiply everything by 2, I get y squared minus 2y equals 2x plus x squared. I'm just going to throw in my c there, so at that stage. Okay, so I've got a plus c, that's the integral. Remember, c is arbitrary, so it doesn't matter if I put it in up here and then I ended up multiplying it by 2. It doesn't matter if I still call it c, because it stands for just an arbitrary constant. So this part now is tricky. So I went to get y on its own. That's difficult here. You'll notice though that this is a quadratic. So remember, a quadratic is something like x squared plus 3x plus 5. But basically, if it has a squared as the highest power, it's a quadratic. And anytime you're solving a quadratic, you expect to get two solutions. So if I'm looking to solve for y here, get y equals 2, I know I'm going to end up with two solutions. So there's different ways of solving this. But we like our quadratics to have 3 terms if I want to have a nice, neat solution. This only has 2. So just to remind you of something called completing the square. If I want to write, let's say, x squared plus 3x plus 5 as a nice, neat equation, I take this, the coefficient of the x, and I half it. So I half it first, then I square it. And after I do that, I'm going to add it and subtract it to the equation that I have here. So I have x squared plus 3x. And then what you put in is you put in your square. Plus 9 over 4 minus 9 over 4. You add it and you subtract it. But I still have my plus 5 at the end. Now what I've done there is I've added something and took it away again, which means essentially I haven't done anything. But it allows me to do something really neat. These first 3 parts, it allows me to factorize them. They will always factorize as follows. You'll have your x here, you'll have a squared here, and the number that goes next to the x will always be the thing you halved. So here it's a positive 3 over 2. So plus 3 over 2. So x plus 3 over 2 to be squared, and then I also have this piece then at the end, minus 9 over 4 plus 5, we're talking 20. What's that? That is plus 11 over 4 here. But I'm going to use that to my advantage over here. So here I don't have a number at the end, but I still do have a coefficient of y. It's minus 2. So when I half it, I get minus 1. Then I square it, that gives me 1. So now I'm going to add it and subtract it. So I have y squared minus 2y, and then add it and subtract it. Plus 1 minus 1 equals, and on the right hand side, 2x plus x squared plus c. Now as I said, this allows me to do something really neat here with the first 3 terms. I can write it as a perfect square. So it'll be y, it'll be something to be squared, and it'll always be the number that I halved, y minus 1 to be squared. Now I still have my minus 1 there, equals 2x plus x squared plus our arbitrary constant. So I've got y minus 1 to be squared. I'm going to bring my minus 1 over. So 2x plus x squared, and I just throw it in there, plus 1 plus c. Okay, now I'm nearly ready to solve. So if y minus 1 to be squared is equal to that, then y minus 1 must be equal to the square root of that. 2x plus x squared plus 1 plus c. Now remember, the square root is a negative and a positive. If x squared is equal to 4, x is equal to the square root of 4. But that means x could be 2 or x could be minus 2. Because if I square minus 2, I'll still get 4. And if I square 2, I'll still get 4. So we have to be able to write this as the negative and the positive of the square root. So y minus 1 is equal to the square root of 2x plus x squared plus 1 plus c. And y minus 1 is equal to the negative of whatever that square root is. 2x plus x squared plus 1 plus c. And lastly, to get y in its own, I just need to bring over that minus 1. So I have 2x plus x squared plus 1 plus c, and then plus 1. And the same on the other side. I've got the negative square root of 2x plus x squared plus 1, plus 1, plus 1 plus c. And then, what have I got, and then my minus 1 comes over to become plus 1. So those are my two solutions there at the end.